Hello everyone. Okay, in this video we're going to be looking at Cert equations, and you're probably asking to yourself, what is an algebraic Cert equation? I'm so glad you have asked. So, an algebraic Cert equation is an equation involving roots of unknown values, i.e. our unknown or a variable is within a square root or a surd. There are two types of equations that we need to be able to solve. So we need to be able to solve equations with one surd or one square root, or equations with two surds / two square roots. What's really important about this section is, note, in all cases, we have to check our solutions, as the solutions of surd equations are not always valid. So we might end up getting two answers, but if we work backwards and sub them answers in, we might find that the two answers don't work out and maybe only one of them is truly valid. So first one is surd equations with one surd. So this is actually very straightforward. If you have an equation with only one surd, we have to isolate the surd on one side, so bring just the surd on its own to one side. We bring all other terms to the other side. We square both sides, and then we solve the resulting equation, and then we get them answers, sub it in, and then check which one is valid. So let's do this one first. X plus root 2x equals 4. So what we need to do is step one, get the surd on its own to one side. So I'm going to have here x minus 4 equals minus root 2x. Now I have the surd on its own. I'm going to square both sides. So this is going to expand out to x squared minus 8x plus 16. And then this minus root 2x squared, well, that's minus root 2x times minus root 2x. The surds are going to cancel out, and the minus is going to be squared, so it's going to become a positive. So I'm going to be left with plus 2x. So I'm going to be left with a quadratic here. Let's solve. So I'm going to have x squared minus 10x plus 16 equals 0. Open up my brackets here. Two numbers that multiply to get positive 16, but add to get minus 10. So it'll be x minus 8, x minus 2 equals 0. Therefore, my two solutions are x equals 8 and x equals 2. So now I have two solutions for x. I need to check which one is valid. So first one I'm going to check is x equals 8. So let's sub it in. I'm going to have 8 plus root 2 times 8 equals 4. 8 plus root 16 equals 4. Remember, when we're evaluating a square root, if we're just evaluating a square root, we just always take the positive, right? So it's going to be 8 plus 4 equals 4. 12 equals 4. Not true. So x equals 8 is not valid. X equals 8 is not valid. So let's check the other one. X equals 2. So but then I have 2 plus root 2 times 2 equals 4. 2 plus root 4 equals 4. Root 4 is equal to 2. 2 plus 2 is 4. 4 is equal to 4. That is valid. So x equals 2 is my only solution here. And that's all we need to do. So the next ones we're going to be looking at is surd equations with two surds. So it's the exact same process and method we're using. It's just one extra step. We might have to repeat the process again once. So if we have an equation with two separate surd terms, we move one surd to each side of the equation. So I take one surd, I put it to one side of the equation. I take the other surd, I put it to the other side of the equation. I have to make sure at least one of them surds is on its own. Then I square both sides. If there are any surds remaining, we have to isolate it and square it like we did in the previous example. Solve the resulting equation, and then we check both of our solutions. So let's do it here. Solve root 5x plus 6 equals 2 plus root 2x. So I have two certs here. Well, I'm lucky out because they're both on opposite sides. So I can now just start by squaring both sides. So equals 2 plus root 2x. Square both sides, square. I'm squaring all of this. So remember, if I'm squaring the left side, I'm squaring all of the right side. So if I'm squaring a square root, they're going to cancel out. So I'm going to have 5x plus 6 equals this squared. And when I multiply it out, it's going to be 4 plus 4 root 2x plus 2x. Now I need to isolate this third, right? So I need to get everything else over to the left-hand side. So if I bring everything else over to the left-hand side, I'm going to get 3x plus 2 equals 4 root 2x. Now I'm going to square both sides. This is going to work out to 9x squared plus 12x plus 4. And this is going to work out to 4 squared times root 2x squared, which is 16 plus, sorry, not 16 plus, 16 times 2x, which is 32x. So 9x squared plus 12x plus 4 equals 32x. Now you solve this quadratic, so bring everything over to the left. 9x squared minus 20x plus 4 equals 0. Open up my brackets here. I'm going to have here 9xx. Now you can factorize this out properly using your group number method, but I have a handy dandy thing called the solutions, so I'm able to skip to this step. So I'm going to have a 9x here, an x here, and then I'm going to have a minus 2 here and a minus 2 here. Just going to vouch for me, that's how it's factorized. Solve it out, I'm going to get 9x minus 2 equals 0. 9x equals 2. X equals 2 over 9. That's my first solution. And then here, my next solution is x minus 2 is equal to 0. X is equal to 2. And that is my second solution. So now we just need to check, do these work out? So I'm going to first now sub in my x equals 2/9. So let's test out that solution now quick. So I'm just doing it because I'm not arsed to do it. Right. So here it is. I sub in 2/9 into my original equation. So I have 5 times 2/9 plus 6, square it all, minus 2 root 2/9 equals 2. Check it out. 2 is equal to 2. That is valid. That worked out. Now I sub in x is equal to 2. Sorry, sub in x is equal to 2. So 5 times 2 plus 16 minus 2 root 2 is equal to 4. Root 16 minus root 4 is equal to 2. 4 minus 2 is 2. 2 is equal to 2. That is valid. So in this case, they are both valid solutions, right? They are both valid solutions in this case. Okay, so let's look at some exam questions that came up on this. So this is from 2019. So this one is actually not really even a third equation. It's kind of more of a third question, really. 2019, paper 1, question 6. Given that x minus root 32 equals root 128 minus 5x, find the value of x. Give your answer in the form a root 2. So, gather my x's on their own. So I have x minus root 32 equals root 128 minus 5x. I'm going to have 6x equals root 128 plus root 32. 6x equals root 64 times root 2 plus root 16 times root 2. 6x equals 8 root 2 plus 4 root 2. 6x equals 12 root 2 x is going to equal 2 root 2. That's my solution. There, bada boom, bada bing. Alright, next one. So this is a one-step Cert equation. So solve root 2x plus 3 equals 2x minus 3. So I have root 2x plus 3 equals 2x minus 3. So square both sides. Squaring the square root, I just get rid of the square root. So I have 2x plus 3 equals, square this out, I'm going to get 4x squared minus 12x plus 9. Solve this quadratic, so bring everything over to the one side. So I'm going to have 4x squared minus 14x plus 6 equals 0, because I brought the 3 over, subtracted, brought the 2x over, subtracted it. And now I have a quadratique that I need to solve. I notice here I can divide across by 4. No, I can't. I can divide across by 2 to kind of make this easier for myself. So I have 2x squared minus 7x plus 3 equals 0. This is going to factorize down to, and it's going to factorize down to minus 1 and minus 3. So let each bracket equal 0. So if I let this bracket equal 0, I'm going to get x is equal to a half, and I'm going to get x is equal to 3. And they are my two solutions here. So let's check if they work. Let's check if x equals to a half. So sub it in. 2 times a half plus 3 equals 2 times a half minus 3. So this is going to be root 4 equals 1 minus 3. Root 4 equals minus 2. Now remember, if I'm just evaluating a cert, I always take the positive. So 2 does not equal minus 2. So it's not valid. Right? Next one. Let's check x equals 3. Sub it in. 2 times 3 plus 3 equals 2 times 3 minus 3. So this is going to be root 9 equals 6 minus 3, which is 3. 3 is equal to 3. Ding, ding, ding. It is valid. So x equals 3 is my solution here. Great. Right, finally, the next one. This is a two-cert equation. So I need to get all my certs to one side. So I have root 5x plus 1 equals 6 minus root x plus 1. Square both sides. I'm going to get 5x plus 1 equals 36 minus 12 root x plus 1 plus x plus 1. So 5x plus 1 equals, no, skip this up here. So bring these terms over to the left. I'm going to have 4x minus 36 equals minus 12 root x plus 1. Can I simplify it for myself? I can indeed. I can divide both sides by 4 if I really wanted to. So that'd be x minus 9 equals minus 3 root x plus 1. So maybe just kind of make the squaring process easier for myself. Square both sides. I'm going to have here x squared minus 18x plus 81 equals 9 times x plus 1. So I'm going to have here x squared minus 18x plus 81 equals 9x plus 9. I'm going to have x squared minus 27x. 81 minus 9 is 72 equals 0. So let's open this up here. Two numbers that multiply to get 72 but add to get minus 27. X minus 3, x minus 24 equals 0. So I'm going to have x is equal to 3 and x is equal to 24. They are my two solutions. Now I just need to check which solution actually works. So let me just move over here. X equals 3, let's try it out. So 5 times 3 plus 1 plus root 3 plus 1 equals 6. Root 16 plus root 4 equals 6. 4 plus 2 equals 6. 6 equals 6. That is a valid solution. Right, let's now check x equals 24. 5 times 24 plus 1 plus root 24 plus 1 equals 6. This is equal to 5 times 24, 100, 120, 1 to 1 plus root 25 equals 6. 11 plus 5 equals 6. 16 equals 6. No, it doesn't. So it's not valid. So x equals 3 is my solution to that equation there. Right, and that's it for algebraic Cert equations. Hopefully this was some help for you, and I'll catch you guys later. Bye.